So we're going to take a quick run through some modern day astronomers. Now we're obviously not going to have time to go through all of the different people who've contributed to astronomy. That would take forever, but we've got some great people to touch on. So following Kepler and Newton, astronomy started to diversify. There were all sorts of people who were interested in just one piece of astronomy. So maybe they wanted to look just at stars, or just at planets, or just at one particular planet. So this created all sorts of different fields for people to be studying. Now the structure and mechanics of the solar system had already been determined. We knew already that the Earth was not the center of the universe. We had a general idea of how the orbits traveled around the sun, or how the planets traveled around the sun in their orbits, that they were elliptical in nature and that sort of thing. And telescopes just kept getting better and better, allowing us to see with more clarity, with more detail, and further out than we ever had before. So first let's start with Edmund Halley, and you may be familiar with his name. He has a comet named after him called Halley's Comet. He used Kepler's laws to calculate the orbits of comets. Now, prior to his time, people believed that when they saw a comet go by, that was it. It just passed by and it was never seen again. But he determined that no, in fact, we're seeing these comets over and over again. They're orbiting similar to the way that planets orbit. They come around and then they're gone and then they come back again. So that was a new thing for people to understand. So then we move ahead to Giovanni Schiaparelli. He was alive during the 1700s and 1800s, and he used the telescope to study Mercury, Venus, and Mars, and he did a whole lot of work mapping the surface of Mars. He thought that he saw an elaborate canal system, and this was one of the ideas that gave rise to the thought that maybe there were aliens living there, and Martians became a common term for beings that would live on Mars. Now, of course, we are exploring Mars very aggressively, if you can put it that way, because we haven't actually been to the surface of Mars yet, of course, but we send rovers out there, and we have a plan in place for hopefully sending a manned mission to Mars in the future. We have not found evidence of life similar to what we understand life to be, but that doesn't mean that there are not the beginnings of life there either. So it'll be an interesting journey to see what's going on in Mars. So then we move to a time when new planets were being discovered. As I mentioned before, the telescope was getting more and more powerful. So we'll take a look at William and Caroline Herschel. These were two German astronomers. They were a brother and sister team, and William was the first one of the two to be studying astronomy. He was just taken by the stars, spent a lot of time with his telescope and such. And then he brought his sister on board, and she did a lot of note-taking for him, and so he'd be looking at stuff and he'd be yelling down to her, hey, write this down, this is what I'm seeing, I just found this, and that sort of thing. But then she progressed into being very interested and, of course, very knowledgeable about what was going on, and so she started doing her own research as well, and when William passed on, she continued his work even further. So they constructed a three-dimensional map of the universe, they discovered asteroids, and in 1846 they discovered the planet Uranus, and of course that was a long ways out, further than anybody else had ever looked before. Next we move on to Johann Galle, and he was alive in the 1800s, and again, as the telescopes kept getting more and more powerful, they were able to see further and further out, and so he discovered the planet Neptune in 1871. Then we go on to Clyde Tombaugh, and he was alive in the 1800s and 1900s, and he used his home-built telescope to discover Pluto in 1930. And of course we don't consider Pluto a planet anymore, but it was the farthest object out that anybody had been able to identify at that point. Then we have Edwin Hubble in the 1900s, and you might notice his name because we have now the Hubble telescope. Now the Hubble telescope was not developed by Edwin Hubble, it was just named after him because of his accomplishments in astronomy. He did a lot of research refining the estimates of the size of the universe and looking at how the universe is expanding, and so that was a lot of his research. He classified galaxies by their structure, so he was again looking a long, long ways out. Then we come to one of the most famous scientists, of course, of our time, and that's Albert Einstein. He lived from 1879 to 1955, and he made a lot of advances and a lot of dramatic changes in what we understood to be true about astronomy. Some people would call him the greatest mathematician and physicist of all times. His brain has been preserved for future study, and it's kind of interesting that the individual who decided to preserve his brain at the start, he would share bits and pieces of Einstein's brain with any scientist that was interested in studying it. And so we don't have a full brain preserved, but a good portion of his brain is preserved. He fled Germany prior to World War II because he was of Jewish descent, and so very important for him to get out of there, and he did. He worked at Princeton University, and there are a lot of different myths that go around about Einstein. He did not really enjoy being in the public eye as much as he was, and so he would do goofy things like you see in this picture, sticking his tongue out and stuff. But some of the things that you hear are things like he flunked algebra. Well, no, he never did flunk algebra. His grades were just fine in all of his classes, but a lot of his professors and teachers didn't really care too much for him. He was kind of smug. Because he knew what was going on, and he was very advanced, so he would get very bored. And so, as you see in this quote here, one of his math professors referred to him as a lazy dog, so kind of an interesting character. He argued that the physics of Newton were only partially correct, and so Isaac Newton, of course, was this really brilliant individual, as you were seeing in the videos that we put up earlier. And he came up with all sorts of theories about how things work and the laws of motion and everything like that. But Einstein said, no, they're only partially correct. At really high velocities and great distances, the laws of motion don't hold up anymore. And he was able to prove that to be the case. So quite the huge change. Of course, his biggest, most famous formula was the E equals mc squared. And it shows a lot of different things, but let's take a look at some of the things that Einstein said. He said that all motion is relative, the laws of physics are the same for all observers, the velocity of light is constant throughout the universe, and of course extremely fast. Mass of an object is related to its velocity, mass and energy are essentially the same, and gravity is a result of space and time being curved by the presence of mass. So let's start by looking at his formula here, E equals mc squared. What this essentially means is the E stands for energy, the m stands for mass, and c is the speed of light. So the speed of light is, of course, a really big number. If you take the speed of light and you square it, so you multiply it by itself, you're talking about a crazy huge number. And if you multiply that by an amount of mass, that will give you the amount of energy that you can get out of that mass. So if you have just a tiny bit of mass, multiply it by the speed of light squared, you're going to get a huge amount of energy. And that's essentially what we see take place in like an atomic bomb. You have a little bit, a few molecules, and it can create this massive amount of energy. This is a huge relationship to understand, because if you can convert energy into mass and mass into energy, that goes to what Einstein was saying, that mass and energy are essentially the same thing. So this was really a radical change in the way that people thought about things. And one of the main reasons, of course, that people saw Einstein as such a brilliant individual. One of the cool things to think about in terms of Einstein is that he had this belief, a faith, that there was a way to unify all of the different theories and understandings that exist in physics, kind of a universal theory. And he believed that because of his religious faith. And so that was kind of his focus and his purpose. Now, he never did find a uniting theory of everything, but that was kind of his life's purpose. So one of the other things I wanted to touch on quickly here is this last point about gravity as a result of space and time being curved by the presence of mass. Now, the way Einstein viewed the universe and the objects in it is kind of like if you took a big blanket and stretched it out across an area, and then you dropped things like planets into this blanket. It would cause the blanket to bow down a little bit. It would cause this curvature. That's the way Einstein thought about space and time, that it was almost like a big blanket, and you put things in it, and that caused it to curve and change the way that it affected things around it. and he talked about that light is affected by that curvature as well. And this would be kind of an example of what he would think of the universe looking like. So here you have the sun, and you've got different planets and their moons, and because they create this depression in the blanket, there would be an attraction. Things would kind of tend to roll towards each other in it. So that's just a very simplistic thought of the way that he viewed the universe. So we skip ahead a ways to Carl Sagan. He was alive in the 1900s. He just died in the 1990s, actually. He researched planetary atmospheres and surfaces, and he explored the history of the Earth, and he taught courses in exobiology. Now, we bring up Carl Sagan because he popularized astronomy. He brought it to people in the form of television, and that was something that hadn't really been done at that point. I mean, obviously we had gone to the moon and that was televised and things like that, but Carl Sagan wrote a book called Cosmos, and he was able to get that book turned into a TV series. And he appeared on The Tonight Show. Now, you guys know The Tonight Show, of course, under a different host, but when that show first started, it was hosted by Johnny Carson. And so Carl Sagan appeared on Johnny Carson's show, and he explained astronomy through using humor. And that was kind of the start of this television series for him. So he did a 13-part TV show. It was hugely popular. It really helped people to understand principles of astronomy and get all excited about it, because he brought out the really cool things to look at about space and to think about where we could go with it and such. And so this really spurred popular understanding of astronomy. He died in 1996, so very recent. So let's jump ahead to Stephen Hawking. He's still alive now. He was born in the 1900s. He's considered to be one of the most brilliant minds of present day. He was born exactly 300 years after the death of Galileo, just kind of a fun fact there. He's a professor at Cambridge University in England, and he does extensive work regarding the origins of the universe. Now, he has a condition that's called Lou Gehrig's disease. It affects the muscles in his body and his speech, so he does communicate through a computer-simulated voice. So while it affects his body significantly, it does not affect his mind. People oftentimes with Lou Gehrig's disease do not live very long, but he has far surpassed the amount of time that people expected him to live. And one of the reasons we think that that's the case is because he has such a drive to understand the universe and to help others understand the universe. So that purpose is pretty huge in keeping him going. He wrote a book as well, A Brief History of Time, and it's one of the most popular books ever written regarding the age and the expansion of the universe. So now we jump ahead to someone who you're probably familiar with. This is Bill Nye, the science guy. He is a scientist, an engineer, a comedian, an author, an inventor, and of course a TV personality as well. He has been working to further the cause of science and increase people's understanding of the importance of being science literate, or being aware of science and understanding the process, and continuing our advancing of technology and understanding in science. So he has been another figure similar to Carl Sagan in popularizing science and astronomy and understanding in those areas. Now, the last one we're going to wrap up with is Neil deGrasse Tyson. And he is another individual who is a TV personality. You see him speaking in a lot of different formats. But he has his background having grown up in New York City, and he graduated from the Bronx High School of Science, earned his bachelor's in physics from Harvard, and his PhD in astrophysics from Columbia University. So he's done a lot of different research type things, but again, another TV personality scientist, popularizing and creating all sorts of interest in science and in astronomy. Now, his most recent thing is he has taken over as the host of the new Cosmos. So they're reviving Cosmos from Carl Sagan's time and updating it with all of the new really awesome stuff that has been an advance in astronomy. So now it's your turn. There are obviously tons and tons of different astronomers out there from all sorts of walks of life and backgrounds and countries and all of that. And you have the opportunity to take a look and see who you can find and what kinds of information you can learn about these different astronomers. So there are instructions in the course for you to follow on finding your individual and what kind of information I want you to share about them. And I'm looking forward to seeing what kinds of interesting things you turn up.